This artifact demonstrates dspy's program optimization pipeline through the MIPROV2 optimizer, which tunes a ReAct agent for question-answering tasks by refining its prompts and integrating external tool calls. The configuration leverages a lightweight optimization mode with parallel execution across 24 threads, targeting exact match accuracy on a 500 example subset of the HotPotQA dataset. You'll observe the initialization of a ReAct module that interfaces with a Wikipedia search tool, followed by the optimizer's compilation phase, where it will generate and evaluate candidate prompts to maximize the specified metric. The setup includes a custom search function that retrieves abstracts using call v2, with the entire pipeline configured to run with the GPT-4o mini language model. Import dspy. From dspy, datasets import HotPotQA. dspy, configure elm equals dspy, lm/GPT-4o mini. Def search query, SDR list SDR. Retrieves abstracts from Wikipedia. Results equals dspy. Call v2 URL equals http://20.102.90.50. 2017/wiki17 abstracts query, k equals 3. Return xtext for x in results. Train set equals x, with inputs question. For x in HotPotQA rain seed equals 2024, train size equals 500, train. ReAct equals dspy, ReAct question answer, tools equals search. TP equals dspy. MIPROV2 metric equals dspy, evaluate, answer exact match, auto equals light, num threads equals 24. Optimized ReAct equals TP, compiler rigged, train set equals train set. This code demonstrates the integration of a ReAct agent with the MIPROV2 optimizer for question answering tasks, showcasing how dspy enables sophisticated tool-using agents with automated prompt optimization. The ReAct pattern combines reasoning and acting capabilities, allowing the language model to iteratively think through problems while calling external tools, in this case, a Wikipedia search function via call v2. This approach addresses common LLM limitations like hallucination by grounding responses in retrieved information. The MIPROV2 optimizer is configured in light mode with 24 threads, indicating a balance between optimization quality and computational cost. It takes the ReAct agent, a training set of 500 HotPotQA examples, and an exact match metric to automatically refine the agent's prompts and few-shot examples. This optimization process typically involves bootstrapping high-quality traces, generating data-aware instructions, and performing Bayesian optimization to find the best prompt configurations. The result is an optimized agent that can achieve significantly better performance than the base implementation, as evidenced by the mentioned improvement from 24% to 51% accuracy. The choice of MIPROV2 over other optimizers suggests a focus on both instruction optimization and few-shot learning, which is particularly effective when you have sufficient training data 500 examples here and want to improve both the reasoning instructions and demonstration examples. The integration with external tools through ReAct's automatic tool selection and error handling makes this pattern especially powerful for knowledge-intensive tasks where up-to-date or specialized information is required beyond the model's training data. Let's break it down. Import dspy. Imports the dspy framework for building and optimizing language model programs. From dspy, datasets import HotPotQA. Imports the HotPotQA dataset class from dspy's datasets module, providing access to the HotPotQA question answering dataset for use in dspy programs. dspy, configure elm equals dspy, lm/GPT-4o mini. configures dspy to use OpenAI's GPT-4o mini model as the default language model for all subsequent operations. This sets the global LM provider that will be used by dspy modules unless overridden in specific contexts.
Def search query, SDR list SDR. Retrieves abstracts from Wikipedia.
Defines a function named search that takes a string parameter query and returns a list of strings, with a docstring indicating it retrieves abstracts from Wikipedia.
Results equals dspy. Call birdie v to URL equals http://20:102:90:50 2017/wiki17 abstracts query k equals 3.
This line uses the call birdie v2 retrieval model from dspy to search for the top 3 most relevant documents matching the given query. It connects to a remote call birdie v2 service running at the specified URL and returns the retrieval results. The query is passed as input, and k equals 3 specifies that only the top 3 matching results should be returned.
Return xtext for x in results.
Extracts the text field from each dictionary in the results list and returns them as a new list. This is a list comprehension that iterates over each item X in results, accesses the value associated with the key text, and collects these values into a list.
Train set equals x, with inputs question. For x in HotPotQA rain seed equals 2024, train size equals 500. Train.
Creates a training dataset by processing 500 examples from the HotPotQA dataset with a fixed random seed of 2024. Each example is transformed to include only the question field as input, discarding other fields. The result is stored in the variable train set as a list of these processed examples.
ReAct equals dspy. ReAct question answer. Tools equals search.
Creates a ReAct agent instance configured to process questions and generate answers, with the search tool available for information retrieval. The agent follows the reasoning and acting pattern, enabling it to interleave reasoning steps with tool usage to solve tasks.
TP equals dspy. Miprov to metric equals dspy. Evaluate. Answer exact match auto equals light. Num threads equals 24.
Creates a Miprov2 optimizer instance named TP, configured to use exact match evaluation, light automatic optimization mode, and 24 parallel threads. The optimizer will tune dspy programs by generating and refining instructions and demonstrations using Bayesian optimization, with the specified metric determining success and parallel execution enabled for faster processing.
Optimized ReAct equals TP. Compiler rigged. Train set equals train set.
Compiles the ReAct module using the provided training set to optimize its performance. The TP compile function takes the ReAct module and the train set as inputs, applying optimization techniques to enhance the module's reasoning and acting capabilities based on the training data. This results in an optimized version of the ReAct module stored in the variable optimized ReAct. This implementation showcases dspy's ability to optimize tool-using agents through the ReAct pattern, where reasoning and external tool calls are interleaved to solve complex tasks. The Miprov2 optimizer takes a ReAct agent configured with Wikipedia search capabilities and automatically refines its prompts and few-shot examples to maximize exact match accuracy on HotPotQA questions. By running in light mode with 24 parallel threads, it balances computational efficiency with optimization quality, demonstrating how dspy can significantly improve performance, from 24% to 51% accuracy, by grounding responses in retrieved information rather than relying solely on the model's knowledge. the integration of CallBirdie v2 for retrieval and GPT-4o Mini for reasoning highlights how dspy orchestrates multiple components into a cohesive, optimized pipeline for knowledge-intensive tasks.
The compiler whispers secrets to Wikipedia, then erases them before the next question.